All right, so we have section 5.2, exercise 22. And here we want the antiderivative of 1 over x log x, I believe. No, log x cubed. Interesting. Okay, so that's like that, dx. So, as I look at things, I guess the most inside thing is this x cubed. So I'll try that. We'll see if that works. It may work just dandy. There may be some other way that works better. But let's try it. U equal x cubed, then du would equal 3x squared dx. And I still have that darn natural log. Yeah, it's not clear what you get out of this. Now, I think we can make it work because, suppose I just try to make it work. Well, I need a 3x squared dx up here. And so the 3 is no problem. I put a 1/3 there, and I'll put a 3. Now, I'll just put the x squared dx. But if I multiply by x squared, I need to divide by x squared. And I already had an x here, so that would make an x cubed, natural log of x cubed. And actually, maybe this does get me somewhere, because then I have 1/3, and the 3x squared dx is just du, and I have u, natural log of u. Okay, well, that does look simpler. Not a lot simpler. But now I see this natural log on the bottom, and the u. Well, the derivative of the natural log of u is 1 over u, so I think my next substitution will be something like v equals the natural log of u, and then dv is 1 over u du. And so that ends up getting me 1/3, and I have my 1 over u du, so that's just dv and v, because log of u is v. So that's just v to the -1. I can do that antiderivative. So that's 1/3 v to the, try that again, v to the -1, right? That's not a power rule, that's logarithm. So there's the logarithm of the absolute value of v plus c. And so that's 1/3 natural log. Now what was v? Well, v was the natural log of u, like that, plus c. And then u was x cubed, so this is the natural log of the absolute value of the natural log of x cubed plus c. Okay, well, now let's try that a slightly different way. So we have, again, we want the antiderivative of 1 over x log of x cubed dx. Well, actually, I can use the properties of logarithms to bring the 3 down and make this the antiderivative of 1 over 3x log x dx, like that. And so that's 1/3 natural log of, antiderivative of 1 over x log x dx. Now, I could go through the substitution and so forth again, but hey, we just did this right there. Whoops, not there. Well, there. And we made our substitution, and so forth, and we got this. So this is with the substitution, maybe I should go back and do that substitution. This is 1/3 the antiderivative of the natural log of yeah, I better do that because I'm just messing up with putting an integral sign in and so forth. So let's do that. Let's let u equal natural log of x. Du is 1 over x dx. And so this is 1/3 the antiderivative of du over u. So that's 1/3 the natural log of the absolute value of u plus c. And that equals 1/3 natural log of the absolute value of natural log of x plus c. Now, actually, notice we had a x cubed there, and so this now worries me, right? I used two different methods, and I got what appears to be two different answers. Now, I know I could bring that 3 down and make this natural log of then 3 times natural log of x, and I could write that as a sum. And so let's look at that. Right, so, well, I guess let's take this, right? So it looks like I got two different answers. So let's take the 1/3 natural log of the absolute value of the natural log of x cubed plus c. And now I can write that as 1/3 the natural log of 3 natural log of x plus c. So that doesn't quite look like that, right? Now I can also say then that's 1/3 natural log of the absolute value of 3 plus 1/3 natural log of the absolute value of the natural log of x plus c. Okay. Now that's a constant. And remember, we only know the antiderivative up to a constant. So this c here is not the same as that c there. Okay, but we still have just added a constant that we don't know. And so actually, yes, this answer is correct and this answer is correct because they only differ by a constant. So it looks like we got two different answers, but not really, okay, because we only know the answer up to a constant. So we could have that answer or that answer. Either one is fine. All right, so that gets us to the end of 22.